Hello, and welcome to our seminar on addressing forward error correction challenges on your 400G device. My name is Steve Sequel. I am the 400G, 800G solution specialist here at Keysight Technologies. So why do we need FEC in the first place? There's a lot of issues with dealing with it. Wouldn't it be nice to avoid it? Well, it has to do with this higher data rate, right? We're constantly seeing higher data rates in the data centers, and with higher data rate, that means your link margins are getting tighter, and that means more eye closure, and eye closure not just in the horizontal direction, with jitter, but in the vertical direction as well with signal to noise. And now with the 400G class, we moved to multi-level signaling, specifically PAM4, and that even aggregates this effect of reduced signal to noise ratio. You lose 9.6 dB of usable SNR when you go from NRZ to PAM4, assuming that the logic levels remain the same. And in the data center, it's different than like the home or office LAN or Wi-Fi was a collision-based system. You really don't have the time at these rates to retransmit a packet that was received bad, that like you would with a Wi-Fi system. Essentially, it has to go through correct the first time, and if it is received, with errors in it, and with PAM4 we're going to see errors in it, then they need to be corrected with all the information, the first time without retransmitting anything. And that's where the first word in forward error correction, forward, comes from. That we're actually going to send the data in advance with the payload data so that if correction is needed on the receiving end, all that information is right there so we don't have to retransmit the data. And what FEC is doing is it really allows us to operate at much lower error rates than where we used to, which we need to do because of these tight link margins in order to get the bandwidth. In the 400G world that we're working at now, the electrical test limits are, criteria limits are 1E minus 5 or 1E minus 6. In the optical side, it's 2.4 E minus 4. That's obviously a pretty bad error rate. But this is before we apply FEC. When we go through the FEC decoder, we get back to a corrected error rate of better than 1E minus the 15th. So it's essentially error-free.